Right. So what does it mean by power? We know that in our DC circuits we studied the basic fundamentals of power, energy, right? So how can we define the power? Shall I define that as the rate at which the work is going to done, or the simply rate of energy transfer in a simple words? So simply the rate of energy transfer, or the rate at which work is to be done, right? We can call that as an power. So what is energy? The capacity to do the work, right? So what in our circuits where we studied in our unit 1, which are excited by DC sources, the voltage and current are always constant. We know that in DC system the voltage and current are always constant. There is no sine wave nature or square nature, right? They are maintaining constant, and we did not even touch the term of the frequency in our unit 1, right? Because that should be purely belongs to our DC circuits, because every circuit is excited by some DC. But while we are shifting on to unit number 2, so it should be we are dealt with the AC supply. So AC in the sense that should be always varying with respect to time, right? Whether how the nature of the wave should be going to change or remains the same, that should be varying with respect to time. Therefore the new term frequency will be come into the picture, right? So here everything we are focusing with respect to time. So in DC, where the circuits are excited by some DC sources, the voltage and currents are we are keeping as constant. So if V and I are constant, what about the value of power? Is it varying or constant in DC?
Constant, sir.
Constant, right? In DC circuits, here, I'm able to write 1 second. In DC, where the circuits which are excited by DC sources, your V and I are constant. Circuits excited by your DC sources, V and I are constant. So therefore, what about power is also constant, right? But now we are talking about AC system, that is your circuits are excited by AC sources. Then what about the value of power? In our DC, what is the formula of power? P equal to
VI.
VI, right? Very good, power. Now we are talking about the circuits which are excited by AC sources. Circuits which are excited by AC sources. Now here in our unit number 2, what we are studying, the circuits which are excited by AC. So during in this case, what about voltage and current which are in sinusoidal quantities, right? V and I are in sinusoidal quantities. What we are studied until now, the average, RMS, form factor, peak factor, right? So these all are varying with respect to these sinusoidal quantities are always varying with respect to which parameter?
Time.
Time. Very
Time.
good. Very good. All are varying with respect to your voltage and current. Both alternating quantities are always varying with respect to your time. So when voltage and current are varying with respect to time, what about the power?
It will also vary.
It will also vary, or simply
Very
we
good.
can call power also a time varying quantity, like your voltage and current parameters. Power is also a time varying quantity. So shall I call this time varying quantity as the instantaneous power? Okay, the instantaneous power, and that should be denoted by same alphabet as P. But somewhere we need some differentiation between your DC sources, energized circuits, the power that is represented by capital P, and in some textbooks, the instantaneous power will be represented by some small p, where we can identify. Okay, or else once we are gone through that problem statement also we can go into identify, or else some authors will clearly represent that as a capital P and instantaneous power as a small p. Okay, but the always remember instantaneous power means at the initial stage this is Va, it will not at all going to vary, but once it should be moving on for time varying quantities where we can also define this average power over a period of time. Since we know that average value should be, what about average value for a full cycle of sinusoidal voltage or current wave?
0.
Zero, right? But then how can we calculate the average power over a particular period of time?
Half seconds.
So we can go for half cycle, but where the power we need to calculate for full cycle. So therefore we can eliminate the average value so that we can go with RMS values. Where we know that RMS values are somewhat little bit of complex, right? Compared to your average value. So here the
Yes.
power will also become as a complex. Okay. So that's why that complex power will be always denoted by capital S. Very important for your short answers. The complex power where you need to take the RMS values. So the complex power which is always denoted by capital S. You know very well in your mathematics. What about complex system? What are the parameters we are having? Z equal to A plus IB, right? Am I correct? I hope everyone is
IB.
right. Your complex numbers, complex systems. Where I is,
Yes, sir. Yes.
where I term is called
Imaginary.
imaginary, very good.
Imaginary.
And A term is called
Real.
Real.
real, very good. If you very well know your complex system, then unit 2 is very easy.
Yes,
Not
sir.
only unit 2, right? Entire AC system is easy. So how to calculate the magnitude?
Under root of A square plus B square.
Very good. Under root of A square plus B square. How can we calculate the angular difference between these two? Theta. Formula phase.
Tan inverse of A.
Right, right. Tan inverse of
B by A.
B by A.
C by
Very good. Very good. These three lines are very, very important for your unit number 2. Where this is your mathematics. In our electrical terminology, we are just shifting your values into some, these AB are the some constants. You can forget whatever the parameter or whatever the alphabet we can represent that. This I should be replaced by J. That is the only difference you need to identify. Remaining everything should be same. All right. So in order to give the differentiation between our mathematics and this electrical, they changed the alphabet as J, remaining everything in order to calculate magnitude and in order to calculate the phase angular difference between these two parameters of A and B, the formulas will be remains the same. And even J and I also, the what is the feature of your J factor or I factor? It should be angle of 90 degrees, right? So one is on real axis, your A term, and another one is in either positive or negative axis of your
imaginary.
capital B, right? So this is what your J factor, right? If it is a J square, then what is the value of I square?
-1.
Minus 1.
Minus 1.
Similarly here also, what is the value of J square? Minus 1.
Minus
Minus
1.
Right? Everything should be remains same, right? Try to understand. And what about J cube?
1.
Hmm.
minus this, sir.
Minus M.
Minus J.
Minus I.
Minus J. Here J.
Minus
Minus
J.
J.
So just you need
Yes.
to
Minus J.
change your terminology I to J. That's it. Okay. So J cube is minus J. And what about J power 4?
One, sir.
1. Very good.
1.
Very good. Very good. So all of you note it down in your margin. This J factor, very important. No need to confuse while you are doing any derivation or problems. Wherever you come across with that J square, J cube, J power 4, and R plus some J theta, everything. R at an angle theta, your polar form, right? I think right done. So here in complex power, so complex in the sense it should be need some conjugate. See, always remember your voltage is constant that is coming from your supply. But depending on your appliance, the current which is drawn by each appliance should be going to vary. Let us take if you are using your mobile charger, that will carry some amount of current. If you use your water pump, your motor, that will draw some heavy currents. Right. Similarly, if you use some LED lamp, that will draw a little bit of current. If you use some filament bulb, therefore that will be consume more, that will
Yes.
draw more amount of current. So based on that current, the power value should be, power consumption should be going to vary. Right. Already we did some exercises during our earlier classes of unit 1. Right, how we can differentiate this power consumption based on your current drawn by the corresponding appliance. We take in different examples. Water pump we take in, grinder take in, LED lamp, incandescent bulb, right? We take in different appliances and we calculated and we came one conclusion that depending on the current drawn by that, the power consumption will be accordingly takes place, right? So here the complex power where I is a conjugate, and shall I write this by after expansion? Will you tell me in trigonometrical form? Conjugate, how can we write that?
I conjugate ultra.
So shall I write like Vi cos phi plus J into Va sin phi
Sin phi. Yes, sir.
in order to remove my conjugate? Let us take V common, I directly written that. Okay, I cos phi plus I sin phi and multiplied with respect to your V. Now this entire Va cos phi, shall I call it as a real term? And this
Yes.
J term, shall I call it as an imaginary term?
Yes, sir.
Right, all of you following that? So now this real term will be indicated by one letter, that is capital P, and this imaginary entire term will be represented by another alphabet, capital Q. Now up to this is clear for all of you, very important. Now so many times they asked for short answers, 2 marks or 3 marks in your JNT. So many times they are asked about your J factor and this power definitions. Okay, complex power, define complex power. Now, so what are the units of this complex power? Simply your volt ampere. Okay, these are the units. And now, see, P plus JQ. This P is which term? Real term or
Real
imaginary?
term.
Real term.
So always remember that is called real power.
Real term.
Since it is a real term, we are calling that as real power. And this is your imaginary term. This is called as reactive power. And the combination of these two, real and reactive power, is called your complex power or apparent power, another name. Understand all of you the different category of the powers? Now what is the first category? Real power. Second one, reactive power.
Reactive power.
And your
Reactive power.
third one, complex or apparent power. This is the
Apparent power.
classification of powers. This is your classification of power in AC quantities.
Apparent power.
Okay.
Sir, your voice is breaking.
So yeah, okay, now it is audible to everyone. Any disturbances? Clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Oh yeah, okay, fine. Ma. So your real power should be always represented by,
P.
right, capital P. And what is the formula to calculate real power?
VI cost.
Very
VI
good,
cost.
very good. Vi cos phi. And reactive power indicated by
Q.
VI sin phi.
Q, and the formula to calculate Vi sin phi.
Sin phi.
Sin phi.
Right. And what about our complex power indicated by S? And that is combination of both. Right. If you wanted to take
VI
the
conjugate.
magnitude of that, P square plus Q square.
Yes,
So
yes,
shall I
yes.
write? Shall I draw the what I call it, the right angle triangle with this expression of P plus JQ? So your S equal to
Yes,
P
sir.
plus JQ, and your magnitude value is P square plus Q square. So shall I draw the triangle, the right angle triangle? Where your real term is capital P and imaginary axis it is capital Q, and therefore your hypotenuse will become S, right?
Yes.
This is your angular difference phi. So from this, will you tell me what about cos phi from the triangle? What is the formula to calculate cosine?
P by S.
Right,
P by S.
P by S.
adjacent side by hypotenuse. Your adjacent side is capital Q and hypotenuse S. Okay. Now this cos phi is called as your power factor. Note it down, very important. This is called as your power factor. From this, what is capital P? S into cos phi. What is S? Your
Cosine.
power, nothing but your complex power.
Complex
Com.
power.
Right? Your cos phi is some factor which is multiplying that power, your complex power. Your S is nothing but Vi, simply. Vi cos phi, right? So this is multiplied with some factor that is called cos phi. So this cos phi is called as your power factor. Very important. And this P is called your real power, or there is another term for your real power. Note it down. Real power is also called as true power. In some textbooks, they can mention as true power. Real power is also called as the true power, or we can also call this as active power. Very popular name, active power. Okay, these are the different synonyms. So simply we can call them as different names with the same parameter of capital P. Now your reactive power, that should be, we can also call as imaginary. And here the units of your active power are simply your watts. I will give one example for furthermore in-depth better understanding of this classification of power. Now the reactive power units are volt ampere reactive powers. Volt ampere reactive powers. You can note down volt ampere reactive powers. And for your complex power or apparent power, units are volt ampere. Done up to this? Still having any queries?
Yes, sir.
Done, all of you? Note down in your notebook.
Yes, sir.
so that once
Yes,
it
sir.
is cleared, I can move on to the new whiteboard. These are very important. Now you can keep it as a box. Power factor, keep it in box. The formula of active power, keep it in box. The formula of reactive power, keep it in box. The formula of your apparent power, that is S equal to VI, simply keep it in box. And this power triangle, very important. See here, simply your J factor is what you are studied in your mathematics, right? How this quadrature, simply if you take
Yes.
E as a parameter, so here angle should be 90. So this is your J axis, that is your imaginary axis, that is J into V. Now if you shift on to the furthermore 90 degrees, that is almost 180 degrees. Okay, so then how it should be become J square V? J square V, in the sense we know J square is minus 1, that is minus V. Right now
Minus
we
B.
got it same on positive x-axis V and negative x-axis it should be minus V. Now if you turn it into furthermore 90, that is 270, then it will become as J cube V. So J cube in the sense minus JV, right? So positive imaginary axis
Manage.
and a negative imaginary axis minus JV. And now you shift on to furthermore, that is 360 degrees, that is J power 4 into V. That is nothing but your V. J power
V.
4 is 1. That is J square into J square minus 1 into minus 1 is 1 V. Right? Will you able to understand now?
Yes.
Right. You just keep enter this J factor in your margin. So whenever you are having any confusion, you can just refer this so that you can clear. So if you are calculating like this, then this is our rectangular form, right? Everyone know that rectangular form. The terminology is very important. The rectangular form, if they are asking, it should be in some A plus IB form, right? If they are asking in polar form. So what is polar form? R at an angle theta, right? This is your polar form, where you know how to calculate R. This is your R, the magnitude, and this is your theta, so that you can convert your rectangular form into polar form. If they are asking in exponential form, the same, right? The same if they are asking in exponential form. So how can we represent Z equal to R
E
into
power IT2.
J theta, right? Just
Oh,
here, I'm writing in terms of J, right? It
J.
may
Okay.
be either plus or minus depending on the expression. Theta may be plus or minus depending on the values, angular difference present in between A and B. Done all of you?
Yes, sir.